Welcome. Before I get started, I want to get a quick show of hands. Who in this audience here is a developer? Please raise your hand. Keep your hand up in the air. Now, who with their hands raised likes wasting time? Keep your hand. No? Okay, a couple people. Well, I'm sorry. There's other seminars for that. Today, we're going to talk about speeding up your development. We're going to talk about taking back some of that wasted time and giving it back to your project or your clients. My name's Dan Shaheen. I work for CodeScience as an engineering lead. That means I'm a developer. I make software on the Salesforce platform. I like going fast. So we've developed some techniques at CodeScience that can help you develop applications on the Force.com platform much faster. A little bit about CodeScience. We were founded in 2008. We've got 75 employees. We've got an office in Chattanooga, Tennessee, and San Francisco, and we've got employees all over the country and all over the world. We've built over 90 products on the App Exchange, and our clients range from humongous companies like Salesforce to really tiny, small, little companies. We empower software as a service businesses by providing professional services on the Force.com platform. That means we write software on Salesforce. We're Lightning certified PDO, and we're the first partner in the product development outsourcing program. That means we can help you make apps. So I don't really have any forward-looking statements, but if I do, don't base your business on them, okay? Anything I say here is, I guess it's just between you and me and 100,000 other people at Dreamforce. So what are we going to talk about today? Well, first we're going to talk about the challenges of a traditional Visualforce workflow. We're going to talk about online versus an offline workflow. We're going to talk about optimizing your static resources and speeding up your development iterations. We're also going to talk about JavaScript, and in particular, the ecosystem built around Node.js and NPM. How can we leverage the tools of the open web to make your Salesforce applications better and faster? We'll talk a little bit about some of the Apex techniques you should use. This is heavily based around JavaScript remoting. Who here uses JavaScript remoting when they develop? Who likes it? Keep your hand up if you like it. I think it's awesome. It's my favorite way to develop on the platform. We're going to talk about how you can annotate your Apex code for performance reasons. We're going to talk about a little bit about using message wrappers. Next, we'll talk about JSR Mocks. That's a library that I developed and we use internally at CodeScience, but it's open source and all of you can use it. JSR Mocks simplifies the syntax of JavaScript remoting. It returns promises. Who uses promises in their JavaScript development? Oh, you're going to love this then. And we're going to talk about how you can run JavaScript remoting offline, not connected to a server, and how you can mock those responses. And that enables you to develop much more rapidly. And it can even enable parallel development. You can work without a server. You can do rapid application design prototyping. You can work completely offline or port existing web apps to the Force.com platform. This is great for doing demos and great for doing the discovery process with clients. You don't have to spin up a whole server. You can sort of mock it out. And then we'll finish off with a live demo. Actually, I'll be kind of switching back and forth between a live demo. So let's do that right now. Let's look at what we're talking about. So here's 2 different pages. Now we're looking at a Visualforce page from my developer server here. Right next to it, we're having some video problems here now. Hang on just a second. Okay. So over here, we've got an offline version of the same page, right? It looks identical. But one is running based on a server, and one is running locally off my computer. So let's look at what this app does. It gets some cards. So we can clear these cards, we can get some cards. It's got autocomplete. So we can start typing, and we can come up with some contacts. This is coming straight out of the contacts on my server. But if we go over here to the offline version, well, we can do the same thing. We can get cards, and we can autocomplete. So how does that work? Well, that works through JSR Mocks, and we're going to show you today how you can write mocks that will respond to JavaScript remoting. Essentially, we've written a shim for the Visualforce object. You know, when you invoke JavaScript remoting, you use Visualforce.remoting manager. We've written a shim for that. So if Visualforce is not available online, we insert JSR Mocks, and that allows us to use a source of mocks to create our JSON. And we'll go into that in depth. So what are the challenges? Why do we want to do this? We're going to talk about online versus offline development, and what's the difference, why you'd want to do one, how you can iterate offline, and then only deploy when your code is right, rather than writing and deploying. And you can use JavaScript in this process to optimize and deploy your static resources. So you can concatenate your JavaScript files, you can crush your images, you can minify your JavaScript, you can vendor prefix your CSS, all without having to do any manual steps. It's all set up in our workflow. So what is the traditional offline development cycle? We're used to this, right? We develop, we bundle, and we deploy metadata. Then sometimes it's a little bit slow. We can expect some delays here. Sometimes the server's a little slow to upload to. Sometimes the process of minifying and all that other jazz that I just talked about, you know, takes a long time sometimes to do manually, so you don't do it every time. We want to get it so fast that you're constantly doing that. And then, of course, you debug online and you repeat. You repeat this cycle. This is how most of us develop for Visualforce. It can be kind of slow sometimes. It can be a little bit frustrating. So the offline cycle that I'm going to talk about today, you develop, you debug, and you test offline. You do this multiple times. You iterate multiple times offline. You tweak your CSS, your HTML, your JavaScript. You use whatever libraries or frameworks that you want to use. And then when it's correct, we bundle and we deploy. This is a little bit faster. This is what we want. We want to speed things up. So next we're going to talk about the Nodejs Ecosystem. We want to leverage the best tools of the open web. How many people develop web pages outside of the Force.com platform, or have? Right? Then you might be familiar with this offline paradigm, right? You've got a server sitting on your desktop. You can iterate. You make a change. Your code changes automatically. So let's go back to what we were looking at here and look at our code. And we'll go ahead and look at one of our components. We'll look at the header, right, where it says, hey now. We'll say, hey Dreamforce. We'll hit save. And we'll go back. The page automatically reloads with my change, right? We didn't have to deploy and wait for the page to deploy and then check it out and make sure it's right and do it again. We can iterate over and over again. As fast as we can hit save, we can see those results on the page. So what is the Nodejs ecosystem? Wow, there's a lot of icons up there, a lot of stuff. You might be familiar with some of these things. In the past, we've used Yeoman as our scaffolding tool to build out our apps. Things like Slush. We've used Bower or NPM to install dependencies, both front-end and developer dependencies. We've used Gulp and WebPack to build our apps, or as a task manager. We've used Heroku and Ant, and we use GitHub, and we use Circle CI, and we use so many different things. It can be a little bit daunting. You've got a lot of choices in the JavaScript universe. So fortunately, that last slide I showed you, this is a slide we used last year. One of my colleagues, John Nelson, made it. In the past year, things have changed a little bit. Things have slimmed down, right? The ecosystem is building itself out. The meritocracy is happening, and people are rejecting some tools and using other tools. So now we're using a lot less. We've gotten rid of Gulp and Grunt altogether in our workflow, and we use NPM as our task manager. And now we're using WebPack as our bundler, and Babel.js, we write our stuff in ES6. Who's writing in ES6 or ES 2015 or whatever you want to call it this week? Okay, a few people. So if you want to use these kind of tools, if you want to use these newer versions of JavaScript, you're going to need tooling like this. So the good news is this stuff is winnowing down, and the best of breed is coming to the surface, and we're starting to figure that out. The two pieces I'm going to talk about the most right now is NPM and WebPack. Who uses NPM? Right? If you use JavaScript, you're using NPM. Whether you're just consuming modules or you're publishing them yourself, there's no better way right now to package and deploy JavaScript, in my opinion. So many projects have used this. Other dependency managers like Bower have kind of started to slip by the wayside, and everybody is focusing on NPM, and this is a very good thing. Also going to talk a little bit about WebPack. Who uses WebPack? Not as many people. So we used to use Gulp and Grunt and write our own scripts, and they would concatenate JavaScript and minify it, deploy it, vendor prefix or CSS, etc. Luckily, a lot of the industry has started moving towards a more standard way. We're using WebPack. If you haven't used it, check it out. It can really speed up your bundling and basically boil down a whole huge project tree full of images and JavaScript and resources down into 1 or 2 files that you're going to deploy as static resources and use in your app. Okay, let's talk briefly about Apex. We're not going to show a lot of Apex stuff, but briefly, the things I'm using in this demo and the things I highly recommend using. A couple of annotations you see up there. Remote action, of course, we're familiar with if you use JavaScript remoting. How many people here use the @read-only annotation? Ooh, almost nobody. Couple people. You want to use that. If your JavaScript remoting method doesn't have to write to the database, using the @read-only annotation means there are no limits to the number of rows you can return from your SOQL. That's big. Now you're limited by 10, I believe it's 10 megabytes, it might be 20 megabytes now for JavaScript remoting payloads, but man, that's a lot. That's a lot of data. And especially if you use what we're seeing below here, if you're using wrapper classes, right? Instead of just returning Salesforce objects, we're going to wrap them in a wrapper class. That means that we can totally control the size, how many properties, and the size of the property names. This can dramatically shrink down the size of the JSON that's going back and forth, and that's going to speed up everything. Combine wrapper classes and read-only annotation, and you're talking super fast performance on your JSR methods. So let's talk a little bit about what I mentioned about mocking. Let's go back to our example. So we see here, we're looking at the version on the server. We can clear these cards. We can get more cards, but I've only got 4 cards on my server. This is just a custom object. And below we can see the JSON that we're getting, okay? So what I was able to do, the simplest way to make a mock is copy the JSON. Copy this JSON and paste it into your mock. Let's look at a mock. Right, so here's the JSON pasted into a plain old JavaScript function, okay? And when JSR Mocks, when you call that JavaScript remoting method, it's going to call this function, and it's going to return this static JSON. Now, if you've got a lot of data and a lot of methods, it's not too scalable. You don't want to manage a big file full of static JSON, so you've got options. Since this is just a JavaScript function, we can do something a little bit better. Let's look at this dynamic method, and let's substitute it in and save. Now let's go back. Our page has reloaded itself. Well, now it's only got 1 card. But if I hit get more cards, well, I've got another one, and another one, and maybe 3 more, and maybe 5, and maybe 10. And I can hit this button until the cows come home, and I can keep adding mock data. Now, this is a humongous time saver for your developers. How many times have you started a project and you don't have good mock data to develop against? Many times, every time. Or maybe you put in a couple of pieces of data on your server, but then every developer needs access to the same data to make sure that it looks the right way every time. Well, using a dynamic mock, we're using Faker.js. Now here's the mock that we used to create what you're seeing. Basically, a mock has an optional error, which we'll show in a minute, and it's got a timeout. This is the number of milliseconds to wait before returning your JSON. Why do we want to do this? We don't want it to happen instantaneously because that's not how it happens on our server. So when we look at our server, we use Chrome's profiling tools, and we see, oh, what's the average time for this JavaScript remoting call to return JSON, and we just use that as our timeout. We could increase or decrease this to whatever we want. Now, a mock is just a POJO, a plain old JavaScript object. That's all it is. Inside of it, it's got a few properties. One of them is a method, right? This is the method that's going to run when your JSR method is called. So it's as simple as that. You can use something like Faker.js to randomize the number of records I'm going to return. And here's where we create random data for each mock card that we create. Does this make sense to everybody? Great. Now, let's clear the cards for a second and look at something like autocomplete. Okay, so here we are on our server, right? And we can type in, what, Benioff. It depends if we want to know about Salesforce or Game of Thrones. Which one do we want to know about? All right, we'll pick Game of Thrones. We'll pick David. So these are coming from real contacts on my server. I can show you the controller if you want to see it. But here, in the mock version, all I did was copy the same contacts into my autocomplete mock and literally wrote a tiny method that does the exact same thing that my server method does. So this is literally doing real autocomplete against a set of mock contacts. Why do I want to do this, right? Well, because we can test our autocomplete, know that it's going to work and render correctly. But what happens if there's an error, right? So if we put in an error, if we just make this true, if you have a property in your mock that is truthy in any way, it's going to return an error. So if we go and reload our page, oops, sorry, I got to save this, right? And we will get errors, which I'll show you at the end in the demo. I'm going to show you how to mock up errors. It's pretty awesome. Oh, here we go. So if I start typing here, we're not going to get anything. All right, let's go back here. Right, our page reloads. Okay, when it's trying to load the cards, we get an error. It says there was an error. We could probably do better than an alert with a message like this, and that's what I'll show you in the demo at the end of this presentation. Okay, so JavaScript promoting has JSR Mocks, rather, has simplified syntax for JavaScript promoting. You guys are going to like this. We return promises. That means we can take asynchronous processes like JavaScript promoting, which returns whenever it returns, right? It doesn't return synchronously, it returns asynchronously. But if you wrap that in promises, you can then chain your promises, you can make things happen in the order you need them to happen in. Mockable offline, which I just showed you, and installable via NPM. JSR Mocks is just an NPM module you can install like anything else. And it works with Angular, we've got a jQuery version, plain old JavaScript, it'll work with ES6, you name it, you can use JSR Mocks. So how traditionally, here's an Angular 1.5 example that shows traditionally how we might use JavaScript promoting and return a promise. It's a lot of code there. It's a lot of stuff going on. Our arguments are sort of shoehorned in on line 83 there. If you have more than one argument, your code gets a little unwieldy. And what happens if you want to take the results of a JavaScript promoting method and pipe those into another JavaScript promoting method? Well, then you're going to indent here and put another one of these in there, and you're going to have the pyramid of doom, right? We don't want that. We want simple, small, almost declarative looking code. So in JavaScript, with JSR Mocks, all you have to do is the following. Specify the method, any arguments, and any options. right? Then when it runs, we can, because we're using promises, we can, it's thenable. We can say .then, do something with the results. And if there's any errors, we can catch that error and do something with those. Here's, again, the mock syntax I'm talking about. Very simple, right? Optional error message. We've got a timeout and we've got a method. But what's nice is your function, your method, is inside of a closure. So there's actually some state here. We can add, if you see the foo property in our mock, we can reference that inside of the function. We can add to it. We can modify it. We can grow it. That's what allows me to keep returning a longer and longer list of cards in my mocked up method. Does this make sense to you folks? Okay, we're going to have a question and answer at the end as well. So dynamic mocks, which I just demonstrated, allows you to not have to copy and paste a ton of JSON. We can write simple, small JavaScript methods that we all know how to write and return sample data. It's as simple as that. Now, once you're using these simple techniques, you enable parallel development. We can separate our front end and our back end code. We can keep the right people focused on the right things. So how many people here are experts at front-end JavaScript and back-end Apex? Okay, I might have a job for you at the end of this. Let's talk. But not everybody is. If you're like CodeScience, you've got a front-end team, you've got a back-end team, and you've got a few guys like me, or gals like me, who can do both and sort of make the connection together. But not every developer has all of those strengths. Let the right people do it. Let the user experience lead the development of your app instead of following, right? Let the experience be first. That's the most important thing. Nobody cares about your beautiful back-end code. Everybody cares about your beautiful front-end HTML. It's just the truth. So we can leverage different disciplines to make better apps. Backend tasks might be defining those remote actions, defining the message wrappers. Those message wrappers then become a contract that your front-end developers can rely upon to do their work. You might integrate various back-end services in Apex as well. Front-end tasks might be creating a single-page app and creating multiple routes there, creating reusable components, developing CSS, front-end testing, and mocking up those remote actions. That's all stuff that your front-end team can work on. Or these can flow back and forth depending on the size and abilities of your team. So what are some takeaways from this? Right? The takeaways here. Faster iterations means faster development. Parallel development equals faster development. Node.js and NPM equals faster development. Faster development means happy developers. What does happy developers mean? Delightful products. Now, I'll let you complete the last one yourself. Delightful products means big money for your company. So you guys want to be using these techniques for sure. If you want to go faster. If you want to go slow, you know how to do that already. So now let's go back to our demo for a second. Let's take a look at what we've got here. So I already showed you how to get more cards. Oh, let's look at error handling. So I'll get rid of my error. I'll go back, and our cards show up. That's great. Let's look at, oops, I got errors here too. Sorry. Right? So let's go back here and autocomplete. Okay, that looks pretty good. Okay, looks the same as my server. Let's look here. Let's look at one of the standard content. Oh, Liz DeCruz. That looks good. Let's look at it on the server. Liz DeCruz. Oh, wait, it looks different. Doesn't look right. We got to fix that. That's a bug. Sorry, guys, there's bugs in my software. Let's fix it right now. Okay, let's go to our controller where we make our JSR method. And, oh, escape is set to false. That's what's going on here. We need to escape it. So how do we get this to the server, though? Well, let's try saying npm run. Oops, no, not production. We want npm run deploy. right? So we've got two ways to deploy. When I do npm run deploy, it's going to gather up all my stuff with Webpack, and it's going to deploy it to the server, but it's not going to uglify or minify the code. That means I can then log into the server. Okay, it's deployed. Let's go to the real app again. Let's reload. Let's type in Liz. Still there. Right? Wait, what's going on here? Let me just make sure we deployed successfully. Let's try that one more time. Great, we see it minifying, deploying. Fantastic. Now let's just open it up straight away this way. Well, sorry guys, I still got a bug. I'm going to have to fix that. How do we do that? Let's look at how we're going to handle errors a little bit more gracefully. Anybody heard of Toaster? Toaster.js? Great for adding errors and messages. So let's do an npm install of Toaster. I'm on Wi-Fi here, so let's hope that it runs fast enough. Toaster doesn't have a lot of dependencies, so it shouldn't take too long. Great. Now let's go back into our code and uncomment a couple of things here. Our CSS.